Alright then, so this time we're going to look at making the ester using the carboxylic acid derivative of the anhydride. So we're still using an alcohol, we're just using the anhydride instead of the carboxylic acid. So ethanoic anhydride, symmetrical. The anhydride functional group then, I'm going to draw that out first. Okay, so if it's ethanoic, then eth, remember, is 2 carbons, so there's carbon 1, and here's your second one. So just a CH3 there. Okay, so there's your ethanoic anhydride. The methanol then, if we just kind of park that up here, so meth is just 1 carbon. Okay, so there's that, that methanol. Okay, so remember what I said last time, that when you're doing the condensation to make the ester, you're going to leave an O on both. So for the methanol then, here's the bond that you're going to chop so that we keep that oxygen on there. For the anhydride, remember the ester functional group, we need a C double bond O next to an O. So if we take this one here, we can break that bond. So we've got our O on both. So effectively this carbon, just like we saw before, is going to join up to this oxygen here. So let's draw our ester then. If I start over here with this CH3, okay, so CH3, then the C double bond O from this bit here, and then this carbon now is going to attach to this oxygen, okay, and then you've got the CH3 at the end. So we've made our ester. So you've got to now look at what we've got left. We've got a hydrogen here and we've got the oxygen here. And hopefully you can visualise that this is going to join onto that bit there. So when you do that, so if I start drawing this CH3 first, okay, and then it's joined to the C double bond O here, and then there's the O. But then if we pop that hydrogen on, can you see what we've made? We've made a carboxylic acid. So we've got an ester, and we can use our naming skills to name that ester. So if we find the oxygen in the chain, we know that that came from the alcohol, so the name would be methyl, and then for this bit it's 2 carbons, so it's ethanoate. Okay, so methyl ethanoate for the ester, and then you can see what we've also made here as another product is actually ethanoic acid. Now the beauty of this reaction, instead of using the carboxylic acid to start with, is instead of it being reversible, it's actually, it goes to completion. So you get a much better yield. Okay, so you get a better yield. The other advantage is you don't need to have a catalyst. So you don't need to heat it up either, and you don't need a catalyst. So that's the reason why we'd use this instead. Okay, so we'll go back to the notes now, but that leave an O on both hopefully will help you to remember which bond to chop here, and then you just piece those together to make your carboxylic acid as your other product instead of the water this time. Okie dokie, thank you, bye.